question number 3. So we have a figure that has a battery with EMF of 15 volt and internal resistance of 4 ohm, and it is being connected to a resistor of resistance 6 ohm. So what is the reading of ammeter and voltmeter in the circuit above? So the voltmeter is connected between the cells, so that is basically asking about okay, so yeah, so the reading of voltmeter will be basically the terminal voltage between this point here lah. Okay, so how do we calculate the terminal voltage? We know that it is gonna be equal to V equal to IR. However, we need the current if we are going to use this equation here, but if you don't want to use this equation here, you can actually use the potential divider punya equation. This is the output over the EMF, so this is gonna be the resistor outside over the effective resistance. So this is the ratio, so it's gonna be something like this. Okay, so it is basically 6 divided by 4 plus 6 times with 15, which will give you the terminal voltage to be equal to 9 volt. Okay, so this is when you find voltmeter first. You can actually find the reading of ammeter first so that you can get the current and just substitute into here, so you'll get the terminal voltage if you have problem using potential divider lah. Okay, so for ammeter reading, it is just EMF equal to I V minus IR. So we know that V is equal to IR minus IR. So it's gonna be IR. Salah pula, terbalik. Sorry everybody, that is actually minus IR begitu. So it should be E. So if you don't remember, you can actually use EMF minus IR. So we know that this is IR. So if we rearrange for I, it's gonna be R plus internal resistance. So I is basically R plus internal resistance EMF. So this is equal to 15 divided by 6 plus 4. So this is equal to 1.5 ampere. Okay, so if you get the reading of current first, you can just substitute into here and you should get the same value. So this is actually the ratio punya method, the ratio of voltage to the ratio of resistance. So you can use this ratio lah, okay, untuk cari. Okay, so that is question A. For question B pula, explain why is the voltmeter reading different from the EMF of the battery. So for this one, it is because the voltmeter, so I'm not going to write it down, you have to listen to it. Okay, so I'm just going to write, listen to what I say. Just in case some of you don't listen to the audio, just basically write everything down. So the answer for question B is because the voltmeter is reading the terminal voltage of the battery. There is a difference in the potential energy between the EMF and the terminal voltage because of the energy that is required to drive each coulomb of charge through the materials of the battery. Okay, so maksudnya dia ada resistance every time dia keluar dari the battery. So that's why the terminal voltage punya value is not exactly equal to the supply voltage by the battery. Okay, so dia berkurang sebab dia perlu limpas all the material. So dia ada dia punya own resistance lah. Okay, alright, so question C pula, how much energy will be dissipated by the resistor after 65 seconds? So the energy dissipated, you can use either by resistor R, so you can either use I square RT ataupun kamu boleh guna VIT. Okay, so it's up to you, but I'm gonna use this equation here. So this is 1.5 square, R is 6 kata tadi. Yeah, 6. And then the time is 65 seconds. So the energy dissipated after 65 seconds is equal to 8.8 times 10 to the power of 2 joules. Okay, So that is how much energy dissipated by the resistor after 65 seconds. Okay, so this is the solution for question number 3.